the sail design that I worked on for a while also led me to the craziest project I've ever worked on in my whole life. And that was designing a wing, but the wing of a pterodactyl, a pterosaur, which, funnily enough, looked a bit like a sail.
Huh.
So anyway, yeah, that was a very interesting sort of segue for me in my research.
What was the practical application of designing a pterodactyl wing?
Well, seemingly very, very little, right? When you think about this, I mean, why would you try to create? And that was what this project was about: a flying replica of a pterosaur that lived 150 million years ago. Uh, Now, from a science point of view, it's fascinating. Can we understand the way that these pterosaurs and the pterodactyl in particular that we were looking at? Uh, can we understand the ways that it flew, that it hunted, that it fed itself, using the fossil record and using knowledge that we have about bird flight, bat flight, and also human flight? So that was a fascinating question. And the interesting thing for me was to really think about the wings of these pterosaurs that were a little different than birds. They don't have feathers; they have a membrane. So it's a membrane wing, which is a little bit like a sail on a sailing boat, but of course horizontal most of the time instead of vertical. Um, and these pterosaurs were really and I'm quoting an aero astro professor that helped me on this project. Pterosaurs were really badly designed airplanes, so it seemed. They must have been very unstable flyers. They had massive heads, big bulky things sticking out in front of the wings. That is not how you design an airplane for nice stable flight. And so what that meant, that if they really did fly as we think they did, they must have been able to control their flight very, very fast, responding to, instabilities. A gust would come and push that big head of theirs sideways. They're going to wobble. They need to be able to correct themselves very fast. And we found evidence. I'm using we now for paleontologists that study this, or we for humans as a whole, not our research team.
I
But
see.
evidence was found of blood flow to the wings, which seemed to indicate that there were muscular um, abilities in that wing for maybe very fast wing shape control. And that was fascinating because then, of course, you start asking yourself the question, can we learn something from that? Can we mimic that now? And could it perhaps have insights that we could apply to remote control airplanes, that we could maybe apply to smart wings in the design of airplanes? Maybe things that could make um, wings more energy efficient, so that we wouldn't need as much thrust in order to stay up in the air or to move fast. So all these questions came up. But it's a slow process, it's not, sometimes people think that new insights sort of happen instantaneously or very fast, but often it takes many, many years to derive insights that are practical. So I would say that maybe we contributed a little bit, but we certainly didn't contribute uh, as much as that we've seen any changes in the way that we're designing. But it was fascinating nevertheless. And we worked on this with National Geographic. They created a documentary called
Oh,
Sky Monsters that
huh.
features our engineering team. Yeah, so if anyone listening want to buy a now very cheap DVD on Amazon, Sky Monsters is the name, and you can see the efforts of the engineering team and the paleontologists also involved with us in creating this replica. And you can see plenty failures. which is great. And you can see me in 2005. Yeah.